Hey guys, today we are just reviewing some forces stuff. I'm not actually going to review all the forces for you because that'd probably be boring to listen to, and I don't know, I really don't feel like trying to get all of that together concisely and without rambling. So instead of giving you a lecture video that should cover all the forces you already know, I'm just going to do some of the problems that you're supposed to be working on. So if you're lost and you need help, you can just watch these videos to see the solutions to these problems. The problem I'll be working in this video is going to be section 4.1, number 2. I've got the image pulled up here on the screen, but the question says to extricate an SUV stuck in the mud, workmen use 3 horizontal ropes producing the force vectors shown below. Find the x and y components of each of the 3 pulls and use the components to find the magnitude and direction of the resultant. Okay, so we've got 3 forces here. This is basically just a vectors problem. You don't even really have to have knowledge of forces, but I'm going to make sure that you guys know how to work out the vectors here. For clarity's sake, I'm going to label these. This top one, I'll label number 1. The one going to the right and slightly up will be number 2, and the one going more down will be number 3. I always suggest labeling things and just using all of your organizational skills to keep track of stuff, especially when you got multiple vectors, which you're going to be doing here a lot in forces. Really good organization is going to be your friend. So part A said we wanted to find the x and y components of each of the 3 pulls. Right now we simply have magnitudes and directions, so we're going to have to split those up, and we're going to be using the vector notation that we've been using for a while with the i's and the j's. Okay, so for force number 1, we've got 2 components, the I component and the j component. The I component is in the x direction. So we're going to look at that one first. In order to do this, you got to split it into triangle, as you should know. You should go ahead and label directions because you can really pick. I'm going to choose conventional, where positive is up and to the right and negative is down and to the left, but you can always choose different convention if you like. So in the x direction, oh, well, and I drew my triangle a little bit wonky for the angle given. You always kind of want the angle to be interior to your triangle so you don't have to do any geometry to get there. So I'm going to make my triangle up here instead of the way I previously had it. But to find this x component right here, that is opposite of the angle, so we're going to have to use the sine function. Sine is opposite over hypotenuse. The hypotenuse is always just your force vector. So we've got 788 is hypotenuse times sine of 32 degrees. And that is my vector in the x direction, which is I hat. Though we do have to be careful here. The reason is because that x is going in the negative direction. So we need to change this to negative 788 sine 32 degrees in the I direction. Then we'll do the y. The y is this component that's in the j direction and is headed up, and it's the adjacent side. So if it's adjacent, we're going to use the cosine function. So it'll be 788 hypotenuse times the cosine function of your angle, 32 degrees, in the j direction. Now, if you're watching this to figure out what to do, go ahead and pause it and try to do the other components, and I'm going to write them out, and we'll see if we all get the same thing. Awesome. So there are my components. I've got F1, F2, and F3 all done out. I left them in terms of the cosine and sine instead of actually calculating out those numbers. I think it's a lot cleaner this way, and it's easier just to see kind of what's going on. All right, so as a side note, I would like to point out that if you try to take the magnitude of one of these things, you should just get the hypotenuse. In order to get the magnitude, you do Pythagorean theorem. You square both components and take the square root of. So if you want to, on your own time, work it out, or you can come ask me and I'll show you because it's really cool. You can use a trig identity to prove that if you take these components, square them, square root, you're always going to get your hypotenuse back. So if you're interested in that, come ask me. Otherwise, we're on to part B, where you've got to find your resultants. So to find the resultants, you're going to add up all of these vectors, which means you're just going to add up each of the components. You'll have to calculate those out as numbers well, actually, I have to type them into a calculator and get your sum of forces. So go ahead and try that. I'm gonna grab a calculator and do it too. Pause the video. Keep going when you've got an answer. And if you get these wrong, check to make sure that your calculator is in degree mode rather than radians. So I got 179.4 I plus 847.3 J, which is in my mind a little counterintuitive. It's not what I would have gotten out of the picture just by looking at it. So that is the total sum of forces. And then we are going to take that and find the resultant, which is going to be the magnitude and the direction. So to get magnitude here, you're going to do Pythagorean theorem. If you need to, you can redraw what that actually looks like. That's 179 in the positive x direction and 847.3 in the y direction. My picture is not entirely to scale. So we're going to want to find an angle and the magnitude. For magnitude, you do Pythagorean theorem, 179.4 squared plus 847.3 squared. Take the square root of, and you should get 866.1 newtons out of that. And for the angle, you're going to have to use tangent, or I guess you could plug our Pythagorean theorem in as the hypotenuse and use a different trig function. But I like using tangent. Is opposite over adjacent. So we're going to do the inverse tangent. Opposite is 847.3. Adjacent is 179.4. Take the inverse tangent of those. It's going to take me a second to type in the calculator, so I'm stalling by rambling. And I get for that 78 degrees. So your magnitude is 866.1 newtons, and then your direction is 78 degrees. And that is, I don't know, is it directionally, I would say above horizontal typically, because horizontal is usually x, but that's not exactly what we're trying to do. So I guess you could say 78 degrees from x-axis. That's the whole problem for number 2. Let me know if you got questions or if you're still confused. That's just splitting up into vectors and then finding a total net force.